Hello everyone. In today's video, we are going to see two past paper questions based on the topic kinematics for year 11 students. Let's get started. Let's see one past paper question. This is the velocity time graph given to us and the movement of the particle is like this and the total time travels is 24 seconds and the maximum velocity reaches to 16 meter per second. The velocity time graph represents the motion of a particle moving in a straight line. Find the acceleration during the first 5 seconds. This is our first question. First 5 seconds starting from 0 to 5. I need to find out the acceleration in between them. We know that in the velocity time graph, acceleration will be the slope of the line. Can we calculate the slope of this line? For this, I need to find out the coordinates of this point. The coordinates of this point will be 5, 16. Let's write down here 5, 16. This will be 5 and 16. This will be 0, 0. Let's write down the slope of the line. Slope of the line will be given as y2 minus y1 over of x2 minus x1. Let's suppose that this point is x2, y2 and this one is x1, y1. Let's apply the formula here. 16 minus 0 over 5 minus 0. That will be equal to 16 over 5. If you divide it, your answer will be equal to 3.2 meter per second square. That will be the acceleration of the particle, which is equals to A. This is my first answer. Let's see the second part here. Find the length of the time for which the particle is traveling with a constant velocity. The particle from time t is equal to 5 to t is equal to 20 seconds. He is going at a constant velocity. He is not changing his velocity. I need to calculate the length of this time. Length of the time will be 20 minus 5. Let's write down here. 20 minus 5 is 15 seconds. That will be my second answer. Let's see the third part here. Find the total distance traveled by the particle. We know that in the velocity time graph, the area under the graph will be given as the distance traveled. If I have to calculate the area of the figure, there are two ways to do it. First of all, divide this into triangles and rectangles. This is your first triangle, this is your second triangle and this is your rectangle. You can add all the three areas and get the answer done. Second part is, you can put the line here and this will be one of the trapeziums you have and this is the triangle you have. You can do any one of the methods and you can solve your question. I will solve it here with the trapezium and the triangle. If I consider that this is my trapezium here, the length A is given as 20. What is my length B here? My length B is 20 minus 5, which is 15 here. What is my height? My height is 16 here. Let's apply the formula here. Area will be given as half sum of the parallel sides. Sum of the parallel sides are 20 plus 15 multiplied by the height is 16 plus area of this triangle. In this triangle, area is half base. What is my base? My base is this one, which is 24 minus 20, which is equals to 4 here. What is my height? My height is 16. Let's write down here. Half base is 4 multiplied by the height is 16. I need to solve that. From 2, if I cancel 4, it will be 2 here. If I cancel this 2 here with 16, it will be 8 here. That will be written as 20 plus 15 is 35 times 8 plus 16 times 2 is 32. Let's write down here. 35 times 8 is 280 plus 32. That will be giving you 312 meters. This is my answer for the area under the graph. Let's see the next question here. A particle moves in a straight line such that t seconds after passing a fixed point O, its displacement from O is s meters, where s is equal to e to the power 2t minus 10 e to the power t minus 12t plus 9. Find an expression for the velocity and acceleration at time t. I need to calculate the velocity when my displacement is given to us. velocity will be given as ds by dt, differentiation of displacement. I need to differentiate this. D by dt of e to the power 2t minus 10 e to the power t minus 12t plus 9. If I differentiate e to the power 2t, my answer will be e to the power 2t only. If I differentiate 2t, my answer will be 2. That will be multiplied by 2. Minus 10 e to the power t is e to the power t only. T differentiated by t is 1. So multiplied by 1. Minus 12t, if I differentiate with t, my answer will be 12. And 9 is a constant term. If I differentiate that, my answer will be 0. This is given as 2 e to the power 2t minus 10 e to the power t minus 12. This is my velocity. Let's find out the acceleration now. Acceleration is dv by dt, differentiation of velocity. We already calculated the velocity. Let's write down the velocity here. 2 e to the power 2t minus 10 e to the power t minus 12. I need to differentiate this function. Let's write down here. 2 differentiation of e to the power 2t is e to the power 2t multiplied by 2 minus 10. Differentiation of e to the power t is e to the power t only. Differentiation of 12 is a constant term which is 0. So that will be 0. I am not writing that. 2 times 2 is 4 e to the power 2t minus 10 e to the power t. That will be your answer for acceleration. Let's see the next part here. Find the time when the particle is instantaneously at rest. When the particle is instantaneously at rest, that means you stopped. That means your velocity is 0. Let's keep the velocity as 0. V is equal to 0. What is my velocity? My velocity is 2 e to the power 2t minus 10 e to the power t minus 12, that is equals to 0. 2 is common in this equation. Let's divide this full equation with 2. I will get e to the power 2t minus 5 e to the power t minus of 6 is equal to 0. This is a quadratic equation. For this, suppose that e to the power t is equal to y. My equation will be y square minus of 5y minus 6 is equal to 0. This is quadratic equation. I need to factorize that. Let's factorize this equation. Y square minus of 6y plus y minus 6 is equal to 0. Y is common from first two. Y minus 6 is left plus 1. Y minus 6 is left and that is equals to 0. Two factors are y minus 6 and y plus 1 is equal to 0. My values for y are 6 and minus 1. Let's put it back here in e to the power t is equal to y. If I put e to the power t is equal to minus 1 and I write down this answer in the logarithmic form, this will be written as t is equal to ln minus 1. Is ln minus 1 possible? No, right? This answer is not possible. Let's see the next part here. E to the power t is equal to 6. In this case, if I convert this into logarithmic form, t will be written as ln 6. Your answer will be ln 6. You can keep the answer like this, or you want to convert it into the decimal form, you can do that. Let's see the next part here. Find the acceleration at this time. I need to find out the acceleration when time is ln 6. What is my acceleration? My acceleration will be given as 4 e to the power 2t minus 10 e to the power t. This is my acceleration. Let's substitute t is equal to ln 6 here. A is equal to 4 e to the power 2 times of ln 6 minus 10 e to the power ln 6. I need to remove this 2 from here, so I will take it as a power here. Let's do it here. That will be 4 e to the power ln 6 square minus 10 e to the power ln 6. This will be written as 4 e to the power ln 36 minus 10 e to the power ln 6. We know that e and ln cancels it out and it will be 4 times of 36 minus 10 times of 6. 36 times 4 is 144 minus of 60. If you subtract it, your answer will be equal to 84. That will be your answer. Thank you so much for watching. I hope you enjoyed my video. Don't forget to like, subscribe and leave a comment down below. Bye bye everyone.